Let's see how you did on this. So for the first one, 3/8. How do we turn it into a decimal, first of all? 3 divided by 8. Good. Which gives us 0.375 or 0.375. Good. So 9/16 is going to be 9 divided by 16, which is 5.625. Good. 5/7 is 5 divided by 7. 1429, actually. So anyway, I told you guys before, math is all about patterns. Once you see the patterns, it's really simple to do calculations. Unfortunately, it takes a lot of experience and years to see patterns. It was much easier to do before there was television. So 5 divided by 12. 416 with the little repeating sign there. 66666. We go in the other direction from a fraction into, or from a decimal into a fraction, requires us to deal with the place values and then reduce fractions. So 0.8 is 8/10, but we do have to reduce that. Both of those can be divided by 2 to give me 4/5. Good. 0.625 is 625 over 1,000. Good. That's the tenths, hundredths, and thousandths. 3 decimal places, so there's 3 zeros in our denominator. Both of those can be divided by 125. Give us 5/8. Now, if you didn't see that they could be divided by 125, you could have seen that they're divisible by 5 or 25. You could have divided that out and then see that there's still another step. It could still be divided by 5. Also, of course, your calculator's automatically reduced for you. Now, I'm going to show you a fancy button on your calculator. If you have the TI-30, it's right near your fraction key. It looks like this. If you have a Casio or Sharp, it's generally just your fraction key. But on the TI-30, you have an FD key like this. If you type in 0.625, it should be able to change that to a fraction for you. You type in the 0.625, hit enter, then you usually have to hit second and that FD key, because it's usually above one of your other keys. Hit enter, and it does convert it. Okay. On the Sharp or the Casio, whatever key you have that turns it into a fraction, the ABC key usually, you enter in that decimal, you hit equals, then you hit that ABC key and hit it a couple of times, and it should toggle it back and forth. If that doesn't work, let me know, and I can look at your particular calculator and help you figure out how it works. So over here, 0.48 becomes 48 over 100, and both of those are divisible by 4. It was 12/25. Now this last one I put up here, if you don't know what that one is, there's no way you're going to figure it out from this, because we haven't gone over how to deal with that repeating decimal yet. Does anybody know what 0.166666 is? 1/6. What you're thinking is it's 1, the 0.666 is 2/3. That's one of the ways you could actually figure it out. Move the decimal point over. Make that 1 2/3 over 10. That would work. 1 2/3 over 10, and you could actually convert that into 1/6. Because 1 2/3 over 10 is 1 2/3 divided by 10. That's 10 over 1, 5/3 times 1 over 10. 5 over 30, or 1/6. It would get you there. For right now, I just wanted to see who could look at that one and recognize it. We have to learn how to solve equations before we can actually come up with an organized way of converting from a repeating decimal back into a fraction. But if it does repeat, if the decimal repeats, we can always turn it into a fraction. It might be an ugly one, but we can always turn it into a fraction. Any questions on any of those? Okay. Well, where I want to start off today is I actually want to start off looking at how do I convert to the nearest set fraction? Like for you guys, it's not quite as important because a lot of your tooling is in decimal. A lot of your tooling will be 0.238 inches. You'll be able to find that tool in your equipment. But in many cases, in many trades, your tooling, is to the half or the quarter or the eighth, 16th, 32nd, and so on. So if you calculate something in a decimal and it comes out to a decimal like 0.238 inches, and let's say my tool set goes to the nearest 16th, how do I figure out what tool in my set to the nearest 16th is closest to 0.238 inches? So I'm trying to convert that decimal to the nearest 16th or the nearest certain fraction. And the way we do that is we take 0.238, we make it into a fraction the simplest way we know how. We can turn anything into a fraction by just putting it over 1. Now you'll note that is still 0.238. The decimal point's still there. So right now it's a fraction with a denominator of 1. What do we want the denominator to be? 16. So how do I turn a 1 into a 16? Times 16. What do I have to do to the numerator? Multiply it by 16. 0.238 times 16. Yeah, at this point in the morning, I'm going camping this weekend. My little hamster's already sitting around a campfire in the lawn chair. I'm sure at this point in the week, some of you feel like your little hamster's roasting over the campfire by now. So I get 3.808. What that tells me is that this is somewhere between 3/16 and 4/16. Which one is it closer to? The 4. Now 4/16 is 1/4 inch. Because you're going to look at your tool set, it's not going to be listed as 4/16. It'll be listed as 1/4. And people ask me that all the time. Well, I thought you said you wanted it to the 16th. Why are you saying 1/4? Well, 1/4 is still the nearest 16th. It's just reduced. Now I'm going to pause for a second. Does anybody have any questions as to where the 3/16 and 4/16 came from here? Because this is 3.8. 3.8 is between 3 and 4. But it's closer to 4 because it's 0.8, yes. So what if I have 0.708 inches and I want it to the nearest 1/8 inch? Tell me what to do. 0.708 over 1. We're going to multiply by 8 because we want it to be 8ths. Very good. So 0.708 is 5.664. So that tells us it is between 5/8 and 6/8. Again, this is 5.6. That's between 5 and 6. Which is it closer to? 6. 5.6 would closer to 6. So, of course, we would 3/4 inch. .411 inches to the nearest 32nd of an inch. Again, tell me what to do. 0.411 over 1. Now, since we're going to the 32nd, we're going to multiply by 32 on top and bottom, which gives us 13 point what? Say that again. 152. Yeah, there we go. So that's telling us it's between 13/32 and 14/32. And it's closer to 13 this time. It's 13.1. So that's 13/32 of an inch. In your notes, I want 0.882 inches to the nearest 32nd of an inch. And I want 0.341 inches to the nearest 16th of an inch. I'll give you a second to work on those. So up top here, 0.882 over 1 times, come on, times 32. I'll do the bottom. 1 times 32 is 32. 14.112. So that is between 14 and 15, 30 seconds. So it's 14, so that reduces to 7/16 of an inch. Down here, 28. Yeah, that does look a little small, doesn't it? What'd you get there? 28.224. So that's between 28, 30 seconds, and 29. I think you multiply by 16 instead of 32. So 28 is closer. So that is what? 7/8. So 7/8 of an inch. Any questions? Okay, so down here we've got the 0.341 over 1. What are we going to multiply here? 16. So at 16 here, what do we get on top? 5.456. And really the 5.4 is all we care about. It's between 5/16 and 6/16, closest to 5. So that's going to be 5/16 of an inch. What if we have something like this, 7.388, and we want the nearest 32nd of an inch? Well, the part in front of the decimal point is a whole number. We don't worry about it. It's just the 0.388 over 1, and then times 32. 0.388 times 32 is what, 12? Or 12 point what? 12.416, which is between 12 and 13, 30 seconds. Which one's it closer to? 12. 12, both of those can be divided by 4. Gives 3/8. So our answer is 7 3/8 inches. What do you think? We will come back and revisit that again before the semester's over. But that is something that is a good skill to have. One of the things this used to be used for is reading a transit. Now I realize you guys are in machining and CNC, so reading a transit and job site layout is not part of your program. However, both the wood construction program and the telecommunications broadband program take the same math course. So I've got to include this skill in here in case one of you decided to jump to one of those other programs at some point. What a transit is it is a method of measuring heights or elevations. So what we would do is we would take a spot that is a known elevation. or just pick a reference spot on a job site. And then we pick another spot to work from. So if this is our job site, we're going to pick this as our reference spot right here. That's the spot that all other elevations are going to be measured from. Then we're going to set up our transit. So you've all seen them before. It's a little tripod thing. And it's got like a rifle scope on it. The old style does. Yes. Now they've got a laser sensor on them for if you can actually do it with solo and not have to have a second person. But then there's a stick here. You have a stick that somebody holds up, or they do have self-standing ones on tripods. The good ones have a level on them so that you're holding them straight up and down. You look through the scope and you see what it measures on the stick. We're going to talk about how to read that stick in just a little bit. But for now, let's say you read that stick and it says 4.82 feet. Some of the newer transits actually do read in feet, inches, and decimal inches, but the older ones went to the 100th of a foot. So let's say I need to take a measurement down here. I put the stick down here and I read it. Would I expect the number here to be smaller or larger than the number here? Larger. Larger number means lower elevation. So if you're down in a hole, you're going to get a larger number. If you're up on a hill, you're going to get a smaller number. I've used to run a construction company in the summers up until the last 2 years. I've seen major mistakes made. A very reputable concrete company in the area. This has been 11 or 12 years ago now. I mean, reputable, they've been in business for a long time and they do great work. But occasionally everybody has one of those bonehead moments. There was a project I was doing some outside work on the farm. It was a new barn that was being built. He was doing the milk house and pouring the concrete in the milk house. The drain was in the center of the floor and was supposed to be 2 inches lower than the concrete at the walls. So he subtracted 2 inches on his transit and he set it at that height and he poured the concrete. Problem was that he should have added 2 inches to make it lower, not subtract. So the drain was the highest point in the floor. That was a mess. There was some jackhammering involved later on. And some new plumbing because the drain had to be reset lower to make it work and all that good stuff. So, yeah, there's some, and to be honest, I can't say whether it was the concrete contractor's mistake or if the plumber came in and set the drain too high and he just went off of the drain. So I don't know, he may have just didn't even double check it and just assumed the plumber was right and poured it quick. Because I know I've been guilty of that too, assuming somebody else was right. But anyway, how do you read a stake? How can this stake read to 100th of a foot? Let me show you. When you read the stake, there's going to be 2 sets of numbers. This number right here, read at the top of the line, is 4 feet. And then there will be lines. Might look something like this. What this is the top of this line here is 4.1 feet. What's happening in between here, and usually these scopes that he had a pretty good magnification so you could read this. What's happening in between here is the hundredths. This line here is 4.01. This here is 4.02. 4.03. Top of the line is 4.04. Notice you read the bottom of the line and the top of the line are separate measurements. 4.05, 4.06, 4.07, 4.08, 4.09, and 4.10. There's a couple reasons for this. If you're looking at measurement, one of the sources of error in the measurement is a line thickness. Like on your tape measure, when you go to measure, if there's 1 inch, pretend those are evenly spaced. Well, if something's lined up with this line, what part of that line is that measurement at? Like, let's say it's lined up right on the 1 here. Well, on a tape measure, it's the center of the line that's actually the 1 inch mark. Well, how do you judge in the center? Well, on the transit stake, on the surveyor's stake, they did away with that by saying it is the edge of the line that's the measurement. So each edge of the line is a separate measurement. So finding the edge of the line is much easier, no estimation involved compared to trying to find the center. Now, I don't expect you guys to be experts on reading these, but it may appear on a quiz where I have something like this. Here is my reference point. And I would probably not do to 1/100 of an inch. I would probably give you a stake that looks something like this. Something like that. Now I'd give you, just hold on, I haven't asked the question yet. Oh, let's see here. You haven't seen me really try to draw anything yet. So I might ask you, compared to the reference, first of all, is point A higher or lower? It is lower because it's a larger number. How much? Well, the reference is reading what? 50.6. 1, 2, 3, 4, 5, 6. Right? Point A is reading 54.6. While we're at it, let's read point B. 49.5. So how much lower is A than the reference? Yeah, we subtract those, it's exactly 4 inches. I might ask, which is higher? A or B? B is higher because smaller number. I could ask the difference there too, and you just subtract them, right? What'd you give me? 5.1 inches would be the difference? Okay, you guys can handle that, I'm sure. Oh, well, the next thing we want to talk about, we've talked about it a little bit, but I want to talk a bit more about this thing. What does that mean? 8 cubed or 8 to the third power, right? How would you calculate it without a calculator? 8 times 8 times 8. It literally means 3/8 multiplied together. And I'm sure you all know off the top of your head that's 512, right? Okay, if you didn't, how would you figure it out? Okay, you can do 8 times 8 times 8 on your calculator. That's not so bad. So let me give you this one. 2 to the power of 12. You're not about to type in 2 12 times because you're going to lose track. If you're anything like me, you're going to lose track. It's going to be 4,096. How do we get that? Well, your calculators all have one of two keys. Most of you will have this key. That's called a caret key. If you're programming on a computer, by the way, in Excel or anything like that, that would be above the 6 key on the computer. So that's your shift function. Shift 6 on a computer gives you that power key or caret key. Others of you might have this key, X to the Y or Y to the X. They both work the same way. You would enter this by hitting 2, then that key, and then type in the power of 12, and it equals. You get 4,096? Sure? That's that confidence we're looking for. I'll reach you on this one. 5 to the power of 6. Yeah, you still lost. 15,625. Did everybody get that to work out? Any questions on it? Okay. No, it's just there's a pattern. When you multiply by 5, there's a pattern. So you just calculate it really quickly. Multiplying by 5s is the same as dividing by 2s. Like if I have 18 times 5, what's 18 divided by 2? So that's 90, right? 34 times 5, what's 34 divided by 2? 17, so that's 170. 23 divided by 2 is 11.5, so 23 times 5 is 115. Let's move the decimal over a spot. Anything times 5, yeah. You divide it by 2 and move the decimal point. Like I said, math is about patterns, but I also mentioned everybody sees different patterns. That's the pattern that I see for multiplying by 5. Other people might see a different pattern when they do it. I showed you those 2 different ways to add and subtract numbers. Some of you may have looked at that second. Most of you are looking at that first way thinking that's how I learned, and the second way makes no sense. But some of you may have looked at that second way and say, oh, that seems to feel better to me. Because everybody's brain is hardwired to do math, but not necessarily in the same way. Okay, so we can do a power. Let's talk about the next part of it. That symbol. That's called the square root. And we know the square root of 25 is 5. But what does that symbol mean? Well, we talked about inverses before. Inverses are operations that come in pairs that reverse each other. They cancel each other out. Like we talked about addition and subtraction. If I just pick a random number, I'm going to pick 13. And I'm going to add another number to it. Let's just pick 4. What is 13 plus 4? 17. Well, if I want to take that 17 and turn it back into a 13, what am I going to do? Subtract 4. Adding 4 and then subtracting 4 cancel each other out. We get right back to where we started. That's inverses. Likewise, if I started with a number 19 and let's subtract 8 from it to get 11. If I take that 11 and I want to get back to the 19, what would I do? Add 8 gets me back to 19. So subtracting and then adding does the same thing. It doesn't matter which one I do first. Whether I add first and then subtract, or I subtract first and then add. They reverse each other and get me right back where I started. We also have multiplication and division. If I pick a number like 7, let's pick another one. We'll do 4. What's 7 times 4? 28. If I take that 28 and I want to get back to 7, I would divide by 4. Multiplying by 4 and dividing by 4 reverse each other. Similarly, if I have 20 divided by 5 would give me 4. If I take that 4 and I want to get back to 20, multiply by 5. And technically, subtraction is defined as the operation that reverses addition. 7 minus 3 equals blank is actually asking us what plus 3 equals 7. And 18 divided by 6 equals blank is asking what times 6 equals 18. That's actually how subtraction and division is one of the ways that they're defined. So back up here. The square root. We know the square root of 25 is 5. But why? Well, what this is asking, the definition of that square root is what number squared equals 25. And we know that, 5 squared is 25. However, what's negative 5 squared? Yeah. A negative times a negative is a positive. So negative 5 squared is also 25. So the square root of 25 is 5 or negative 5. There's 2 possible answers there. Now, most of the time, since we do live and work in the real world, most things are positive, unless you're talking about my checkbook. But most of the time, we are dealing with positive numbers. We don't have negative lengths. We don't have negative weights. You guys in your programming in CNC will have negative coordinates. You might have a 0 point that's in the middle of the part. Normally, it's the lower left corner of the part that's your 0 point, but you may sometimes have a 0 point that's in the middle of a part, and you would have negative coordinates. So, square root of 81. Again, many of you may know that, but if you don't know it, how do you punch it on your calculator? Most of your calculators are going to require you to do a second or shift. If you have Texas Instruments, it's the second key. I believe your Casios and Sharps use a shift key. And the square root is usually above an x squared key or something like that. To use that button, you have to do the second square root. So second or shift, and then that square root key, then type in the 81 and hit equals. What does it tell you? 9. Yeah, of course. Oh, you do have the square root key is on a main key for you? Okay, it's not a shift? Okay. Some of yours, if you have a 1 line, you do have a 1 line display, yes. Yours, it's a reverse notation. You punch in the number and then hit your square root, yes. And on yours, you don't even have to hit equals. It automatically calculates the square root as soon as you hit the button. The calculator, of course, only gives you the positive possibility, but be aware that there is a negative possibility when you do a square root. Nah, if you give me just the positive, you're good. Yeah, I've never had anybody do that before. What's that symbol mean? Third root. Yeah, that's asking what number to the third power equals 27. Some of you actually have a third root key on your calculator. Others have to use an N root or X root, depending on how your calculator is set up. Some of your calculators, some of the Casios I know do this. they have an x. Actually, they use a y to the 1 over x, like that. What you would have to do if you have one of these keys, you would type in the 3. You would press that key. You may have to press second or shift to get that key. And then you would type in the 27 and hit equals. If you have this key, you would type in the 27 first, hit that key, and then the 3, and hit equals. It should give you 3. Because 3 to the power of 3 is 27. Everybody get it to work? Okay. Okay, let me see your calculator. No, that's next to the third. You want above it, there's a third root key. So you can do second and then that key. That gives you a third root. And that would do it. But for generic ones, let's see what you got here. You've got an X root key right there above your caret key.
Oh, okay.
So like for generic ones, you'd put in 3, shift, then that key, then 27. That'll do the third root. That'll do any of the other roots. Okay? So that's the key you're looking for there. TI-84, you've got to use the math button. So on the TI-84, you would type in 3, press math, then you actually arrow down to option number 5, which is the X root, and then type in your 27. Now that actually does have a third root function in that menu you probably saw, but any generic root will work with that X root function. So like if I wanted to do the fourth root of 81, same thing. I'd type in my 4, hit that X root key, and then 81, and you are correct. It does give you 3. What's that? Yours? On yours, you got a 1 over X key. So you're going to type in 4, then you're going to hit shift, that X root above the caret, hit that key, 81. So it's that one above the shift and then your caret.
The number shift.
Then caret. Yep. The index of the root, so the 4 or the 3 or whatever, then shift caret, then the number. Nope, let's see your key. Let's see your calculator. Here's I think you've got a Y to the 1 over X key on this one. There it is. You've got an X. You take 4. Nope, you've got to go the other way. You've got to type in the 81 first. Then you hit second, the YX,
Okay.
and then put in the 4.
Oh, okay.
So you've got to go backwards. You got to put in the number first and then the root and the index. So I want you guys to try this one. The 5th root of 3,125. See if you can make your calculator do that one. It is 5. Now I'm going to have you guys try a few of these here now. I want you to do square root of negative 36, the third root of a negative 125, the fourth root of negative 64. Second root now. How about a fourth root of a negative 625? A fifth root of a negative 243. A sixth root of a negative 15,625. And a seventh root of a negative 128. So for the first one, the square root of 36, or negative 36, you're getting an error, right? Why is it an error? Well, because remember, that is asking what number squared equals a negative 36. Any number squared is going to be positive. You cannot square root a negative number. Now, I tell you that here because we're dealing with real numbers in this class. If you were to go on to a four-year university and take a college algebra class, well, they do have something called I, where they made up a whole number system that allows you to take square roots of negative numbers. We're not going to deal with it. It would be 6i is what it would be in that imaginary system because of the negative. But for our purposes, since we're dealing only with real numbers, we're not in the theoretical algebra world, you cannot square root a negative number, period. But how about the second one? Give that one a shot. Give people a second to try that. Should get a negative 5. Yeah, let's see what you got. So if we do 3 second caret negative 125.
Oh, shit. I can put this.
I'll use the subtraction key. Yep, you gotta make sure you use the negative key. Shift is right there. So you're going to do 3 shift caret. Where's your negative here? Negative's right there. Negative 125. Oh, what the heck? 3 shift caret. Might have to do parentheses. You gotta do parentheses around your negative number and put it in. You may have to too. You may have to do 3 shift caret and then do parentheses, negative 125, close your parentheses. You do it. Did everybody get it to come out to negative 5? Yeah, yours did work now? Good. How about the next one, the fourth root of negative 625? Yeah. Anything to the power of 4 is going to be positive because there's 4 of them. You seen a pattern developing yet? What is it? Yeah, the even roots or the even powers are always going to give a positive answer. So since a root reverses a power, we cannot take an even root of a negative. So you can guess which one of these 3 over here is going to give us an error. The 6. The other 2 will work because they're odd powers. Okay, it is time for our break. So it's 8:20. Let's take a break till 8:30.